Hi everyone, CDNet here with another update from the Avalanche ecosystem. Today we have another quite special video. I have with me here Tyler, Tyler from both Ava Labs and Sherpa Cash. And we're going to talk about Sherpa Cash and specifically their ceremony today. But Tyler, maybe you want to introduce yourself first.
Yeah, hey everyone. I'm Tyler Smith. I work for Ava Labs on the Avalanche platform. And recently I've joined the Sherpa team as an advisor and been doing some development work, especially lately around the trusted ceremony setup that will be starting in a few hours. Yeah, I think that's pretty much it.
Cool. And then maybe a little intro on Sherpa Cash as well. Like why would people want to use Sherpa Cash?
Yeah, so what we want to do at Sherpa is we want to start laying a foundation for privacy in the Avalanche ecosystem. I think there definitely is a big misconception with crypto that it is somehow more private than regular finance, which is very much the opposite of the case. If you buy something on the street from somebody, say like a food vendor, and you give them a $5 bill, literally nobody knows about that except the two of you. It's up to the two of you to report that to whoever you're required to report that to. But it's not like in crypto where that transaction gets broadcast to the entire world. So what we really want to do as our first goal at Sherpa is to try to bring the privacy available to Avalanche users to be more in line with what you would get when you use cash. If you take, for example, the Avalanche C chain, if you take somebody's account and you go look at their page, you can see literally all of the financial activity that they perform on the C chain. You can see which centralized exchanges they use. You can see which decentralized exchanges they use. You can see which pairs they buy, what price they got in at. All sorts of information that a lot of people don't want to know. Somewhat, recently Vitalik Buterin dumped a whole bunch of meme tokens, and everyone was watching it on Twitter in real time because if you go to Etherscan, Vitalik Buterin's Ethereum address is literally marked as owned by him because there's just really no privacy available by default in these crypto systems. So there's a project that started on Ethereum called Tornado Cash that utilizes zero knowledge proofs. It uses an algorithm that was first created for Zcash, a paper called Zero Coin, but now is a currency we call Zcash. So Tornado Cash brought this technology to Ethereum, to the EVM platform. And so our first goal at Sherpa is to bring that technology to Avalanche and make it available for Avalanche users. So that's our goal at Sherpa.
Yeah, and the way it works, right, is you deposit a certain amount of AVAX in there. To my understanding, you kind of get a receipt of some sort, a secret code, a secret, I think is what it's called. And that one, it's kind of just a text file. You could even write it down. You could do whatever with it, and whoever inputs that same secret again would be able to at some point withdraw your AVAX. It could be yourself, it could be someone else.
Absolutely. So, typically for a crypto transaction, you have address A and B, and you send a transaction that says send 10 AVAX from address A to address B. But that is how obviously we go and we can check out Avascan and we can see where all your transactions go. With Sherpa, you go to the app and you're presented with a couple different pools. For example, 1 AVAX, 10 AVAX, 100 AVAX. You deposit that number of tokens into it and you get back what is sort of like a claim check, like you said, an encrypted note. And this is sort of like a one-time use private key that we use to transfer your funds from A to B without that being linked on chain. So when you deposit your funds, you provide a hash of your secret. that gets stored on chain and committed to it. It can't be changed. And then later, anybody that knows that encrypted secret can generate a zero knowledge proof that basically says, hey, I know the secret to a deposit that was made earlier, but I'm not going to tell you which one. And then there's some cryptographic trickery with a second hash that we use to make sure that you don't double withdraw. So when you deposit, you provide one hash, and then when you withdraw, you prove that you know the input for the first hash, and then you provide a second hash that proves that you have not withdrawn from that hash previously before. So in essence, you'll have a smart contract. We'll have a bunch of open deposits, deposits that people have made and then not withdrawn. And so whenever you go and you make a withdrawal, we can't know for sure which open deposit that came from. So if there are 1 million deposits that have not been withdrawn and I go and I make a withdrawal, that could plausibly be any one of the 1 million deposits that was previously open that I withdraw now. There's no way of knowing which one it is. And so that is how you get privacy. And the more users that the protocol has, the larger that we have of the pool, the more useful it is, obviously. Yeah. If only you and I are using the Sherpa pool, then any withdrawal is going to be one of the two of us.
Yeah.
If we get millions of people using it, then to some very high degree, you're essentially anonymous. At least for the amount of money that we have, the TVL of the ecosystem, right? So similar to how in like a DEX like Pangolin, there's liquidity. So maybe Pangolin has $50 million of liquidity in it. So if you want to go sell $100 million worth of assets, you're not really going to be able to do that. If you want to sell 1 million, you're going to be fine. So similar to Sherpa. So the goal is we want to have a high TVL so that no matter how much AVAX you want to try to keep private, there will be the basically anonymity liquidity available to do that.
Yeah. And then to, of course, make it anonymous and make it cryptographically secure. That's kind of what the ceremony is for, right? Correct.
So we're using a technology called zk-SNARKs, which is a type of zero knowledge proof. And so I was saying before, there's the two hashes, the deposit hash and the withdraw hash. The zero knowledge proof we use basically to prove to the world that those two hashes are derived from the same secret input. The claim check you got correlates to one of the deposits with the withdraw hash that you're making, but not which one it is. That's the zero knowledge part. So we're proving it's one of the deposits, but you can't know which one it is.
Yeah.
Yep. And that is where the on-chain unlinking between the addresses happens. But one property of zk-SNARKs versus other types of zero knowledge proofs is that they require what many people call a trusted setup. I'm not a huge fan of that term myself, but it's really kind of impossible to get away from at this point. But essentially, for the zk-SNARKs to work, you have to create this key verification material. And if somebody knows the sort of the secret entropy that was used to create this verification key, then they would be able to forge invalid proofs. So to be able to use a zk-SNARK securely and reliably, you need to really be comfortable that the key verification material that you're using has been generated securely. And so to do that, we do a process that has come to be called a ceremony. It's also called a multi-party computation. And you can kind of think of it like a bunch of people who don't trust each other coming together on the internet and cooperatively building a public key for which no single one of the people participating knows the private key for it. And the only way to sort of construct this private key would be if every single member of the ceremony collaborates to reconstruct it. So you only need one single party, to be honest, which is why I'm not a huge fan of the term trusted setup, because we've now scaled ceremonies to where essentially anybody who wants to participate can participate in it. And as long as you participate in it, you can trust yourself, hopefully. And so as long as you participate in it, you know that one single contributor has contributed honestly. And so there is no trust. So it's only a trusted setup if you don't participate yourself. So we are having the ceremony and strongly encouraging anybody who's interested in using Sherpa or just interested in contributing to the security of other people who might want to use Sherpa to join our ceremony and contribute. And, you know, we're aiming to get at least 1,000 people. Tornado Cash on Ethereum, they got a little over 1,000 contributors to their ceremony. At the time, it was the largest ceremony ever held. It might be still, I'm not sure. But we would love to get more contributions than that, if possible.
I'd love to beat that, yeah.
Yeah, that would be great. You know, and yeah, I don't think that there's really any chance that we're going to get less contributions than that. I think we have a pretty healthy community. So
we have a very active community, I think. And I think, yeah, it's good to emphasize that as for anyone who contributes, as long as they, you know, don't put their contribution on YouTube or something, like I think we're about to do, at least for me, for one of them at least, because I can contribute multiple times, right?
Absolutely, right. Yes. You can contribute multiple times, and it's actually beneficial to everyone if you contribute multiple times, especially if you use different pieces of hardware or different browsers, so that in the very slight chance that, you know, one system is compromised, if you've contributed from 2 different systems, then in order for your contributions to be invalidated, both of the systems would have to be compromised. So I personally am going to make a number of contributions. I encourage everyone else who is interested to do so as well. When you make a contribution, you can contribute anonymously, or you can contribute and link it to your GitHub or your Twitter profile. So I will be doing both some public contributions as well as some anonymous contributions, and doing so from different hardware. So you know, definitely feel free to contribute a few different times if you'd like to.
Yeah. What is the benefit of connecting it to your Twitter or GitHub?
A couple things. One, for us, it's a good publicity. I know, especially in the Tornado Cash ceremony, the way that they ended up getting to be the largest ceremony in history was because it really blew up on Twitter when people started sharing it. It also it provides a commitment to the community that you did in fact make this contribution. So say somebody wasn't able to contribute, maybe they joined the community later on, or for whatever reason they're unable to contribute to the ceremony, but they trust me and they trust you enough that they think, hey, well, if Tyler and CedarNet contributed to the ceremony, then I'd feel comfortable with it. By sort of linking that to our social media and by us tweeting it out and telling everybody, hey, we really did contribute to this. To the degree that the trusted ceremony is a trusted ceremony, that provides some of the trust. Yeah. And the last thing is that we are doing an airdrop of Sherpa tokens, and 1,000 people who contribute entropy will be selected to receive some of those airdrop And in order to be eligible to receive airdrop tokens, you're going to need to link it to either your GitHub or your Twitter account. That way you can't churn out 1 million anonymous contributions and ring the thing. We're a little smarter than that.
Yeah. It's good. It's good. Let's get into it, maybe. I think it's best if I share my screen, right?
Yeah. I think that sounds good.
And so share my browser. So
perfect. Yeah. So I will say just I know we talked about this before, but for everyone else, this right here is a test ceremony, sort of a dry run. The real ceremony will start in a couple hours, and these previous test contributions will go away. So we're going to do this this test run here. But by the time this video goes live, when you go to ceremony.sherpa.cash, you should be seeing the real ceremony. So when you go, the first thing you're going to see is a list of all the other contributions that have been made up until now. You can see that there's some that are anonymous. There's some that are linked to people's social accounts. I think most of these are probably from the same people, but we can't know. It's part of the beauty of the ceremony. So it's really straightforward. There's a contribution button. You can click that to get started. You'll be prompted, whether or not you want to do it anonymously or you want to link it to your account.
I'll do it anonymously for this video, so I don't have to log in.
Perfect. Yeah, that'd be great.
And then it's just any random input.
All right, good. Yeah. So here's where you're going to be prompted to input your entropy. You can source this from pretty much anywhere you want. You can get block hashes. You can generate random numbers on your Raspberry Pi. You can just mash on the keyboard. You can use a password generator, whatever you want.
URL.
Ideally, it's unpredictable, but it's up to you. And it can be as much or as little as you would like. Generally, the longer it is, the more entropy. Not necessarily if you are like using a Wikipedia entry versus just a bunch of like random numbers. But yeah, in the sum total of everybody coming up with all of the entropy that they can works together to even out maybe some of the weaker contributions.
And what kind of characters does it accept?
I mean, anything you can put into a web form.
Okay.
I mean, pretty much anything, I think. Yeah.
Cool. So I just press contribute, right, with youtube.com/c/cdnet.
Absolutely, yeah. So you put in whatever, and when you're ready, you push contribute. This will start the process. So what's going to happen now is it's going to contact the Sherpa server. It's going to get the latest contribution that has been made by whoever contributed before you. It downloads that and is going to run some somewhat heavy computations in your browser that apply the entropy you just provided to the previous contribution. That will generate your contribution, and then it will send that back to the Sherpa server. So then when I come in after you and I want to contribute, it's going to pull down the contribution you're making now, and I'll apply mine on top of it and send it back. And in that way, it's sort of this single file, sequential, one after another, everybody taking a turn to add their entropy to the process.
And then it's just stacking the randomness on top of the randomness, right?
Yes. Yep.
Yeah.
And so at every step of the way, as long as you are not broadcasting the entropy on YouTube like we're doing now, every step of the way, every contribution is theoretically making it just a little bit more secure. So now you can see the contribution, the calculations are finished. Your contribution is complete, and it's been uploaded back to the Sherpa server, and is now available for the next person to contribute.
Yeah.
Yep.
Do I need this hash for anything?
Yeah. So that's a great question, actually. So as the people in charge of the server that you're using, when you go to when you go to ceremony.sherpa.cash, obviously this is a server we are hosting. So some people have asked, what advantage does that give us in the process? What can we do as the people operating that server? So we can't manipulate your contribution in any way. The one thing that we could potentially do if we wanted to, if we're, pretend we're malicious or want to sabotage the ceremony, in theory, what we could do is we could censor your contribution. We could say, we don't want CedarNet to contribute. He just sent us this contribution. We're going to ignore it. And when the next person comes along, we're going to give them the contribution before his and just pretend that he never came along and did anything. So if you're worried about us doing that, you can save this hash. And when we finish the ceremony at the end, we publish all of the contributions. And so you can come along later and you can make sure that your contribution is in fact included in the final ceremony results. So if we were to try to hide your contribution and pretend that it never really happened, then later after we end the ceremony, you can come along and you can check and you can say, hey, I made this contribution and it's not in there, what's going on? This also goes back to, tying it to your social. If you contribute with, say, your Twitter account, and then afterwards you tweet out and you say, hey, this was, I contributed to the Sherpa ceremony. This was my response hash. Then other people can check for you. You don't necessarily have to do it yourself. There's also some later on when you say, hey, I contributed with this hash, but it's not present. People can go back and see, he really did contribute. No, here's where he was talking about how he contributed with this hash and it's not present. So something suspect is going on.
Yeah.
So anyways, that's a long way of explaining the point of that hash, but yeah, it's there so that you can make sure that we don't try to censor your contribution.
Yeah, and that's good information, right? Because this is an important secured part of it, right?
Yep.
Apparently I got a gift from Zoom. And of course, all the calculations take place in your browser, right? You mentioned before. So it's not taking place in your servers. You do not know like what entropy I put in. You just know the resulting hash kind of.
Absolutely. All our server does is kind of shuttle the contributions between users. All of the secret information stays totally inside your browser. You get the public contribution from before you. The secure entropy that you provide gets applied totally in the browser. And then the result of that is a new public contribution. So nothing sensitive ever leaves your browser. And I'll say the Tornado Cash guys from Ethereum, they've done a lot of great work, but one of the things that is really great is they wrote a WebAssembly version of some of the SNARK calculations that is what really made it feasible to do all of this in the browser. So if you don't trust the browser, there are instructions on the website for running the software with
From
different
source code.
implementations, and you can do it, yes, totally from source and totally inspect everything if you want. But that's not necessary if you don't want to, thanks to this WebAssembly support. So that's great. If it wasn't for that, the contribution that you did before, which took less than a minute, would have taken much longer. So
okay,
that's also why this ceremony is able to scale to 1,000 plus people. A lot of people may be familiar with tales of older ceremonies from Zcash where you had a dozen people flying over Chernobyl with Geiger counters to try to really generate the most secure entropy they could, because doing these calculations was so difficult. You just couldn't scale this ceremony to more than a handful of people. So it's being able to contribute in the browser in less than a minute that is what makes it possible for us to create such a large ceremony. So we're very thankful for the work that they've done.
awesome. So let me maybe just summarize everything for the people at home, right? So the ceremony is so that you know for sure that that every secret proof kind of that you can use to claim a deposit from Sherpa Cash, that it is secure. If you put in something that nobody else knows, you know for certain it's random, it's secure. If you do contribute some entropy, you call it, do contribute to this ceremony, you do stand a chance to get one of the 1,000 airdrops. And then, of course, after the entropy is ready, you'll work on getting everything else ready for Sherpa, right?
Yes, absolutely. All of that is 100% correct. So once the ceremony ends, which is not at a predetermined date, we will kind of see how contributions go. As long as contributions are coming in, I would like to keep it open, but once we sort of get to a critical mass of the number of contributions we're going to get, then we'll end the ceremony, and we will be able to get the final SNARK verification keys and can deploy the final contracts. I will say one quick thing that I'm excited about is that originally when Tornado launched, they launched before they had their final ceremony. So there was code in the contracts that allowed what they call the operator to later change the SNARK verification keys, which isn't, obviously ideal. They had that for a while. They've now set that to the 0 address, which means that nobody can change it anymore on Ethereum, which is good. But in our case, fortunately, we are going to have the ceremony done before we deploy any of the contracts to mainnet, which means our contracts are just going to, from the very beginning, never have the functionality to change the SNARK keys at all. So after the ceremony happens, we'll get the SNARK keys, we'll deploy the contracts to mainnet, and then they're set in stone. We will never be able to change them after that. So after that, we'll be able to launch the Sherpa website, and people will be able to go and start using it. So we're really looking forward to that.
Awesome. That sounds good. I think that's all from my side, all the questions I have. I'm not sure if you can tell us something more about when you're expecting to launch, or is that still up in the air?
It's still up in the air. Like I said, I would like to run the ceremony as long as we can, and we can't predict how long that will be. We'd like to keep it open at least a week. I'm thinking, maybe a week or two for the ceremony to run, and then we can do just some final testing on mainnet and make sure everything is okay. There's one other piece of the ecosystem, which is called relayers, and this is an untrusted entity that is just used to essentially broadcast transactions. And we're working on some final setup to get relayers in place before launch. So I think that's the last thing. So no firm date, but it's getting very close. We're getting all the loose ends tied up, and it should be pretty soon.
All right, looking forward to it. I think for everyone at home, I would encourage you to participate in the ceremony. Not only will you know for sure that the randomness is truly random, you will also stand a chance to get a little bit of Sherpa. Tyler, thank you so much for your time and for your explanation, and of course for building cool projects both with Ava Labs and with Sherpa Cash. And thank you from my side, of course, also for being a viewer, because I know you view the channel. Any last words, or do we close it there?
No, I think that's good. I think we'll close it there. Thank you so much for having me and letting me explain what we're doing to everyone. And I just hope I encourage you to participate in the ceremony. If anybody has any questions, feel free to reach out to me. I'm around the community, or you can find me at twitter.com/tcrypt25519. If you have any questions about Avalanche, Sherpa, zk-SNARKs, whatever, feel free to reach out.
Awesome. I'll include that in the description of this video as well. Then
awesome,
for now,
thanks.
Everybody, thank you so much for watching. Hope you enjoyed it. See you in the next one, and goodbye.
Bye, guys.